So on questions like the following, you would want to get both of your terms to have the same base because once exponents have the same base, you can set their exponents equal to each other. So for example, I have 81 equals 3 to the power of x minus 2. Luckily, I can rewrite 81 as 3 to the power of 4. So that will equal 3 to the power of x minus 2. And again, because my bases are both the same, being 3, I can then go ahead and set 4 equal to x minus 2. And I'm going to go ahead and solve for x by adding a 2 on both sides. So that means x will be equal to 6. You can always just go ahead and check that by plugging the number back in, but it still holds true. All right, so moving on to maybe a little bit more advanced example here. Again, same thing can apply. So I have 3 to the power of x plus 2 equals 9 to the power of x. I can rewrite my 9 to the power of x as 3 to the power of 2x, and that would be because 9 is the same thing as 3 to the power of 2. Raising that to the power of x, when I have power to a power, I just multiply my two exponents together, which is how I get that 2x there. So in case you're wondering why that works, that is why it works right there. So now I will have 3 to the power of x plus 2 is equal to 3 to the power of 2x. So I can set my exponents equal. X plus 2 equals 2x. And then to solve for x, I'm just going to get all my x's on one side, subtract x from both sides to get 2 is equal to x. Okay. So if we're good on that, let's move on to our final example here, which looks like a lot, but when we break things down, it actually is not too bad. So again, even though there's a log in my exponent, I have a base of 4. 64 is equal to 4 to the power of 3. 4 times 4 times 4. So I can set that now equal to 4 to the power of log base 2 of 2x minus 6. Again, the key here is to make sure that our bases are the same, and then once we do that, we solve just the exponents. So I get 3 is equal to log base 2 of 2x minus 6. And to solve this type of log equation, I am going to go ahead and convert this to exponential. So I will have 2 to the power of 3 is equal to 2x minus 6. 2 to the power of 3 is 8, so 8 equals 2x minus 6. Add 6 to both sides, I get 14 equals 2x. Divide both sides by 2, and I get 7 is equal to x. So even a question that can look as daunting as this one here still works the same exact way as the previous two examples. We just want to get our bases to be the same. Usually if you see a question like this, one of the bases will be what you want to set it to, so that makes it kind of easy trying to figure out how to get one to match the other. Go ahead and set those exponents equal to each other and then solve for x.